All right, folks, so what's a perfect square? A number whose radical is whole. Perfect. Should have no problem filling that in there. You all set? Yeah? We sure? Okay, so your first one was a 1 right here, right? What's your last one? 400. Everything else is good in the middle. Do you need more time to fill those in or no? William, you need a couple more minutes? James, how about you? 2 more. Chase, how about you? You're good? Okay. All right, so if you look at the top, it says dividing, doesn't it? Okay. Excuse me. When multiplying and dividing radicals, tell me, do you have to have the same radicals in order to multiply and divide? No. So, you do not need like radicals. Meaning, you can multiply a radical 3 with a radical 7, no problem. You can divide a radical 3 with a radical 7, no problem. New today, when you are dividing, you cannot leave a radical in the denominator. Where is the denominator, folks? The bottom. And that's fraction, right? Now, folks, fractions and dividing go hand in hand because you all know that the fraction bar means to divide, correct? Okay, so we cannot leave a radical in the denominator. We have to fix it. And there's a special long fancy word that means to fix it, okay? You must rationalize. That's what it's called when you start with a radical in the denominator and you get rid of the radical in the denominator. How do we do that? Well, this means we're going to multiply the numerator and the denominator. Did I say only the top or only the bottom? Both of them. You must multiply the numerator and the denominator by the radical in the denominator. And then, of course, you're going to simplify. And you all know how to simplify. We're breaking them down and looking for pairs. Because pairs represent perfect squares, correct? Okay. Questions on what we've written in so far? Are you sure? All right. Well, let's take a look at number 1. Is number 1 a division problem? Yes, the fraction bar means divide, right? Okay, so the problem is I have a radical in the denominator, correct? I have to rationalize that, and we just wrote in that if we want to rationalize it, you're going to multiply the top and bottom by the radical in the bottom. Well, what's the radical in the bottom? Radical 3, correct? So I'm going to multiply the top by radical 3, and I'm going to multiply the bottom by radical 3. So, folks, this 2 is not under a radical, correct? And that 3 is under a radical, correct? Am I able to multiply those? No. The ones outside of the radical stay outside the radical. The ones under the radical stay under the radical. So if I multiply 2 times radical 3, what are you going to tell me? 2 radical 3. Everybody doing okay? Okay, now look at the denominator. Those are both under the radical, correct? So I'm allowed to multiply those, right? What do you get? 9. So this will be radical 9 in the denominator. What do you notice about the denominator now, though? That's a perfect square. It's still a radical, but it's a perfect square. What is a square root of 9? 3, which means I can get rid of the square root of 9 and just turn it into a 3. And now there's no more radical underneath there, is there? Does that make sense? Now I want you to know that we're going to have to look to try and reduce the 2 on the outside and the 3 in the bottom. Meaning, can I divide this 2 and this 3 by the same number? Answer is no. I am not concerned with this radical in here. Are we clear on that? Question though, would that 3 under the radical break down into anything? No, so we're finished. We tried to reduce it, we tried to break down the radical, that's it. Let's take a look at number 2. Problem here is that there's a radical in the denominator, right? What is the radical in the denominator? So that means I have to rationalize it. I'm going to multiply the numerator and the denominator by radical 5. Multiply across the top for me, folks. What do you get across the top? Say it again. There we go. Negative 1, radical 5. Remember that negative 1's outside of the radical, right? Okay. How about across the denominator? What do we get down there? Just a 25? Radical 25. And that's perfect square, isn't it? What is it? It's just 5. Notice there's no more radical over that 5 anymore on the denominator. Now you need to ask yourself, can this 5 under the radical break down into anything? No. Can the 1 over 5 be reduced? Can I divide those both by the same number? No. Then we're done. All right, number 3. What's the problem with number 3? Where is the radical? Denominator. So what do I have to multiply by? Radical 7 over radical 7, top and bottom. You guys remember how we did equations? Whatever we did to one side, we had to do the other? Same idea here. Whatever you do the top, you got to do the bottom. Okay, multiply across the top. What do you get? Good, William. What do we get across the bottom? Not just a 49. Radical or square root of 49, right? What do you notice? You get 7 down there, don't you? Okay, now ask yourself, can I break down this 7 underneath that radical? What does the 7 break into? Nothing, so we can't do anything there. What about 7 over 7? Will that reduce? In fact, it'll just all cancel out, won't it? Notice that only the 7s that are not underneath the radical are what's going to cancel. I still have a radical 7 left. Is that okay? Not all of the 7s cancel out, only the 7s that are not underneath a radical. Okay, what's the issue with number 4? The radical 11, right? So what am I going to do? Top and bottom by radical 11. So multiply across the top for me. What do you get? 4 radical 11 over radical 121. What is the square root of 121? 11. So this is 4 radical 11 all over 11. Notice this bottom now has no more square root in it, right? Now, can I take this 11 and underneath the radical and break it down any further? Will 11 split into anything? No. How about 4 over 11? Can I divide those two by the same number to make them reduce? No, so we're done. Okay, guys, before I get to number 5 over there, I want to make sure that you're seeing the pattern that's happening here. Do you all see that radical? And then when we're done, look at my denominator. Do you all see this radical? Now look at my denominator. You all see this radical? Look at my denominator, right? You all see this radical? Look at my denominator. Do you see the pattern that's happening there? You're basically making your own perfect square by multiplying by the bottom radical. We all good? Okay, so take a look at number 5. Now, when I throw in number 5, I get kids that try and tell me to multiply by 2 square root of 13. But the 2 is not the issue. I can have that 2 down there, can't I? I just can't have the radical down there. So that's the only thing that I need to multiply is radical 13 over radical 13. Leave the 2 alone. That's not the problem. Okay, multiply across the top. What do you get? Good. Now, over. Did that 2 go anywhere? No, it's still there, isn't it? Correct. And what is the square root of 169? So this is now negative 3, the square root of 13, over 2 times that 13 that no longer has a radical over it because it was perfect. Everybody still doing? You following here? Okay, well, what is 2 times that 13? 26, you said? Okay, now we get into the simplifying if we need to. Can this 13 split into anything? It's prime, isn't it? Can 3 over 26 be reduced? If you're not sure, put it in your calculator. 3 over 26. Does it stay 3 over 26 or does it reduce to something? It stays 3 over 26, so you're done. Okay, I believe that's the front. How are we doing? Just fine? Any issues so far? Okay, let's flip it over to the back. Now, on the back, oops, am I on the back? Yes, on the back, we've got another one that looks like the one we just did. So what's the problem here? The radical 2 is down there, right? So how do I get rid of it? Multiply radical 2 over radical 2, top and bottom. Multiply across the top, and what do you get? Multiply across the bottom, what do you get? Good. Is everybody following James here? He's spot on. He's doing perfect. Okay, well, what is the square root of 4? So this is really negative 3 times 2 down here. And what is negative 3 times 2? Now, folks, does it matter where I put the negative symbol? You can put the negative down there with the 6. You could put the negative, whoops, what's going on here? You could put the negative up with the 5. Everybody see that? Or you could put the negative in the front like that. Questions for me? You sure? Because we're going to start to get into some bigger numbers here. You ready? What's the issue with number 7? It doesn't matter that there's 2 radicals. Where can I not have a radical? On the bottom. The numerator's fine. I can have a radical up there all day. No issues. So what am I going to multiply by? Okay, so now when you multiply across the top, what do you get? 54? Because those are both under the radical, so they both can be multiplied together, right? Okay, how about in the denominator? Radical 9. Well, we know what radical 9 is, don't we? It is 3. Now, that 54 that's up there, can 54 be broken down? Absolutely, right? So that's what we need to do next. We need to take this 54, and we need to try and break it down and look for pairs. 9 and 6, he says. 9 goes to 3 and 3, and the 6 goes to 3 and 2. Okay, so look at what we have here. Did you have anything in front of this radical 54 to begin with? No. Do I have any pairs? Pair of 3s, so that means a 3 comes out. What's left underneath? 2 times 3, which is 6. Everybody see this 2 and that 3? Okay, now take a look at what you have up there. We already reduced the radical, right? There's no more radical in the denominator. Can 3 over 3 reduce? Just, you can put the 1 out there if you want to, but you don't have to. If you put a 1 in front of there, that would be A-okay, but you don't need to. Okay, what's my issue with number 8? I don't care that there's 2 radicals. The bottom one is the one I care about. How do I fix it? Multiply by radical 15 over radical 15. Okay, multiply across the numerator. What do you get? Radical 75. How about the denominator? Radical 225. Well, what's the square root of 225, folks? 15. Now, can 75 be split up? Yes. What do you want to split it into? 25 and 3, he says. And how about the 25? Okay. So, did I have anything outside of my radical to begin with? No. What do I have pairs of? So that 5 will come out. How about what's left? The 3. Now, we already took care of the radical. The question is, does 5 over 15 reduce? What can I divide both 5 and 15 by? By 5. By 5. If I divide 5 by 5, what do I get? I don't really need to put the 1 in front of there, but if you want to, you can. What about 15 divided by 5? 3. Now, can you reduce this 3 over that 3? No, because 1's under a radical and 1 is not. How we doing? We're kind of getting into a lot of steps here. We're doing okay? Got a question for me, William? Okay. Yeah, don't do the radicals. Just do 5 times the 15 and then put the radical over it. Okay? All right. How's everybody else doing? Okay? Ready to move on? Okay. Now, I just want to make sure that you all don't forget how to multiply. We know how to multiply these, don't we? We're going to multiply those two numbers together. What do you get? How much? Radical 2 over 9. Everybody doing okay? Now, bad news, it's a fraction under a radical, right? Good news, there's an easy way to fix it. Anytime you take the square root of a fraction, it's the square root of the top over the square root of the bottom. Is that all right for everybody? What do you find in there that you like? The square root of 9. What is the square root of 9? So it looks like that. Can you break this 2 down at all? Do I have any problems with this? Is this radical a problem? No, because it's in the numerator, right? That's it. That's that answer right there. Okay, do the same thing with number 10. Two and 13/16. Now that definitely looks a little bit strange, right? But you should be able to change this mixed number into an improper fraction. Remind me, how do you change this into an improper fraction? Oh, you guys learned this a long time ago. Let's go. What are you doing? Okay, now your calculator will do it for you. Above the ABC button, does everybody see the ABC button? Do you see above it, it says ABC to DE? Do you see how the A is big on the ABC? That's like the whole number. Do you see the DE right there? That's just a fraction. So if you have 2 and 13/16, if you press second and then that ABC button, it'll turn it to 45/16 for you. Now, let's say you didn't really know that, because you don't really have to know that. I'm going to go ahead and write it down here for a minute. You were taught to take the big number times the bottom, 2 times 16. Then you're supposed to add the top number. And what'd you get? 45. And you keep it over the 16. We doing all right? Okay, now there's a fraction underneath there, which means I'm going to do the square root of the top over the square root of the bottom. What do you like about this now? Which is what? 4. So now I have the square root of 45 over 4. Will 45 break down? Yes, it will. What does 45 break into? Say it again. 8 and 5? Oh, that's 40. You're close, Autumn. 9 and 5. There you go. And the 9 breaks down to 3 and 3. So what's going to get out of there? A 3. What's left underneath? And what do we have in the denominator? Okay. So that 5 doesn't break down anymore. How about 3 over 4? Does that reduce at all? It does not. It stays just like that. So, what do you think about dividing? Do you see how fractions and dividing go together? Yeah. Okay. I think I got one more row. Okay. All right. Well, this one's a fraction under a radical. So how do I change that a little bit? Correct. We're going to do the square root of 2 over the square root of 7. Keep going. You're on a roll, sir. Is that okay? Radical 49. What is the square root of 49? Okay. Will the square root of 14 break down? It will, but what does it break down into? Do those break down any further? Do we have pairs of anything? No, which means it's just going to stay as a square root of 14. Can I reduce the 14 and the 7? No, because one is under the radical and one is not. All right, go ahead and multiply there for me. Two-thirds. And that is definitely under the radical because those are both under the radical. Okay, so how do I change it a little bit? Make them both radicals, two separate radicals. Now, what's my issue? Okay, so what are you going to do? Okay, so what's your new numerator? Nope, numerator. Over denominator. What is the square root of 9? Okay, now how about that radical 6? Will that 6 break down? It will. What does a 6 break into? Does it go any further? Do we have any pairs? No, so it just stays as radical 6. Can you simplify that 6 and that 3? No. All right. Do we have multiplying to do in the next one? Yeah? All right, go ahead. 1/2. That's nice. So that's under a square root though, right? I'm going to take that big square root and break it into two little ones. Square root of 1 over square root of 2. What do you see about this that you like? 1 is a perfect square, isn't it? What's the square root of 1? 1. Okay, but what's the problem with this? Bottom radical 2, right? So how do I get rid of it? Top and bottom. Perfect square. Good. Folks, do you have to put this 1 out front? You don't. Is it wrong if you do? No, it is not wrong if you put that 1 out there. Some people just like it. Makes them feel better that there's something in front of there. Okay, one more, we'll call it a day. Multiply for me. 9 over 5, you say? So it must have been 1 4/5. Is that what it was when you multiplied? You told, what's that? Oh, just straight up 9? Oh, I thought you said 9 over 5. I'm sorry. I must have just not heard you, right? You just got a 9, right? Period 9? Oh, that's nice. What's the square root of 9? 3. Okay. Doing all right? In a second. So, dividing. You cannot have a radical in the denominator. Can you have a radical in the numerator? Yes. Look to break things down. Look to reduce.